Welcome to Seakeeper's Voyages of Discovery. I'm your host, Katie, and today we're taking a little trip to Catalina Island to study one of the most charismatic mammals in our oceans. Before I introduce to you our human guests today, let's get to know our cetacean friends and explore what they're experiencing in the deep blue. It's no secret that dolphins are highly social animals with sophisticated communication systems. They produce a wide range of vocalizations, including clicks, whistles, and pulsed sounds, which they use to convey information, coordinate group behavior, and establish social bonds. One of the most remarkable aspects of dolphin communication is their use of echolocation. Dolphins emit high-frequency clicks, which bounce off objects in their environment. By analyzing the echoes, they can perceive the size, shape, distance, and even internal structure of objects, helping them navigate, locate prey, and avoid obstacles. If this isn't impressive enough, each dolphin has its own unique whistle signature, similar to a human fingerprint. These signature whistles are used for individual recognition and social bonding within dolphin pods. They also use specific whistle patterns to convey identity, emotional state, and other information to their fellow pod members. Communication plays a vital role in maintaining social cohesion within dolphin populations. By exchanging vocalizations and engaging in coordinated behaviors, dolphins reinforce social bonds, establish group hierarchies, and cooperate in activities such as hunting, mating, and caregiving. Now imagine yourself beneath the surface, surrounded by the gentle chatter of dolphins as they communicate, navigate, and hunt in their ocean home. For dolphins, sound is not just a means of communication. It's essential for survival, guiding their interactions, and helping them navigate through their complex underwater world. But what happens when the tranquil soundscape of the ocean is disrupted by the deafening roar of a passing cargo ship or the boom of Navy sonar? For dolphins, the consequences can be devastating. Studies have shown that the intense and high-frequency sound produced by Navy sonar can disrupt dolphin communication, disorienting them and interfering with their ability to locate prey and navigate effectively. It's like trying to have a conversation in a crowded room while someone blasts an air horn in your ear. In some cases, the impact of sonar can be even more severe, leading to stranding events where dolphins become disoriented and beach themselves in a desperate attempt to escape the overwhelming noise. But it's not just Navy sonar that poses a threat to dolphins and other marine mammals. Commercial shipping, offshore drilling, and underwater construction also contribute to the cacophony of noise pollution in the ocean, further disrupting the delicate balance of marine ecosystems. So what can be done to protect dolphins and other marine life from the harmful effects of noise pollution? It starts with raising awareness and advocating for responsible ocean stewardship. And I think right now, one of the best ways to do this is through collaborative science. The long-term effects of noise pollution aren't yet realized, and our guests today exhibit a remarkable companionship, working towards safer oceans for our beloved marine life and more responsible navigation of these ecosystems as humans. And now I have the honor of introducing a voice you may have heard before, the esteemed Captain Tom Peterson of Discovery Yacht Valkyrie, as well as a new guest on our show, an incredible scientist and ocean advocate, Dr. Ari Friedlander from UC Santa Cruz. Welcome.
My name's Ari Friedlander. I'm a professor in the Ocean Sciences Department at UC Santa Cruz, and I'm the Director for Research for the California Ocean Alliance. I'm originally from Connecticut. I did my PhD at Duke University and focused my research on using new technologies to study marine mammals and understand how the animals interact with their environment and how those animals are then impacted by disturbances, whether they be environmental or human-induced.
That's great. And Tom, can you please introduce yourself, your first name and last, and give us some background info on yourself?
Sure. My name is Tom Peterson, and I am a volunteer through the International Seakeeper Society, where our involvement is various forms of marine research programs. I am not in that arena professionally. I work every day in the insurance industry. But my background I was a marine biology major in college and owned and operated a dive company and organization in the 80s and used to run commercial dive boats. So I've been in, on, or under the water my whole life, and this just keeps me fully involved in the marine world.
Well, perfect. Let's chat a little bit about the expedition that you all embarked on in September of 2022. Dr. Friedlander, can you tell us a little bit about the goals of this expedition?
Yeah, so it's a project with a number of different international collaborators and partners, and the overall objective is to better understand the behavioral and physiological responses of oceanic dolphins to Navy mid-frequency active sonar. So to do that, what we do is we locate groups of dolphins around Catalina Island as our sort of our primary area, and then we place a number of acoustic recording packages in the water around the animals. We then fly a drone above the animals so that we can record continuous video of those animals and their group composition. And then we set up our team so that we have a large underwater microphone that plays a synthetic Navy sonar to the animals. And then what we do is we basically watch for this behavioral response from the drone, as well as from folks on the main boat and up on a cliffside. And after the experiment is over, which takes about half an hour, we do sort of 10 minutes of pre-exposure period. Then the exposure takes about 10 minutes. Then we stay with the animals for about 10 minutes after that. Once the experiment is over, we actually go in and we start collecting small tissue biopsy samples, little skin and blubber samples. And we continue to do that for about an hour or an hour and a half after the experiment. And what that lets us do is look at stress hormone levels, cortisol levels in the animal, and see if the animals have sort of increased their stress levels during the experimental phase, and then how quickly it then dissipates afterwards. So it's a whole bunch, and then the acoustic recorders are measuring the vocal or the acoustic response of the animals, as well as how loud the sounds are that they're hearing. So sort of from above, from below, and from within, we're trying to understand how Navy sonar impacts these animals, which are very common in the area and are very likely exposed to sonar pretty regularly.
That's really interesting. So Navy sonar would be a form of noise pollution then for these animals, is that right?
Exactly. So, the areas where we're working are proximate to the naval ranges where they do a lot of this testing, but those sounds propagate pretty far, and sometimes they make those, they use sonars off of the range. So yes, it's an added acoustic pollution, yes, to their acoustic environment.
How long have you been doing this type of work?
We've been doing behavioral response studies to try and understand the response of different types of marine mammals to Navy sonar for close to 20 years. This project specifically is interesting because before this project, we really focused on individual animals where we would place a tag on them, and the tag measured the sound that the animals heard and that they made. But those typically were species that were more rare, that you didn't find in high numbers around Navy ranges. And we've moved to this type of experimental design because we now want to know about the animals that are very abundant, and that largely they probably make up a large percentage of the animals that are exposed to this Navy sonar, even if they're very abundant. So understanding it from a group perspective is really important because these are very social animals. The groups of dolphins we're working with can be 5 to 10 or up to several hundred. So they have very tight social dynamics and group cohesion. So understanding how those are impacted or affected by exposure is what the main questions revolve around.
That's really interesting, and we'll get into some more about methods and results and everything like that. But I'd love to hear from Tom how you learned about this expedition and what made you interested in hosting this on your vessel. And can you tell us a little bit about your vessel as well?
I've actually done a couple of other projects with Dr. Friedlander up in Monterey Bay with whales. We've done at least 2 times in the past. So we were familiar with each other from the beginning there. But the connection was back through the International Seakeeper Society. Dr. Friedlander had contacted Tony at Seakeepers, described the project and what was needed, and we were put together once again. So this was again kind of this particular project was my third time working with them, but on a slightly different marine mammal program. The first two were whales, and this particular one was more dolphin oriented.
I'd love to hear about the expedition from your point of view, if you can tell us what you learned from these animals and what you experienced while you were there.
Katie, this was a very unique and very different type of experience for me. Although it was looking at behavioral studies of the dolphins, it was behavioral studies from artificially created sound and unique sounds that they would be exposed to underwater. And it really was fascinating to watch and observe firsthand, because how in broad base the experiment would be to monitor a pod of dolphins for a little while, and then create the sound, introduce the sound to the pod, and then record any behavioral changes. And the very first time it happened, it was really eye-opening to me, because all these marine mammals that had just been playing and jumping around and kind of in a random order suddenly turned side by side and lined up and started advancing toward that sound. And they broke it off once the sound was over. But it was very fascinating that there was some very orchestrated changes to their behavior from the introduction of that sound.
Do either of you have some hypothesis for why their behavior changed like that?
We're sort of at this point trying to, it's not difficult to say how the animals changed their behavior. It's difficult to say why and sort of what the reasoning was. But when you add in the changes in the group composition, as well as the changes to their acoustic behavior, it gives you a little more insight about, was the reaction, was it strong? Was it weak? Did it include both of those parameters? Does that likely mean that the animals were responding for a long time, or just, very quickly or transiently?
Dr. Friedlander, can you tell us your thoughts on this expedition, on being hosted on Valkyrie, and how that contributed to your research?
Yeah, so when we plan these research sort of opportunities or expeditions, we are a pretty tightly knit group, and everybody that's coming out has an expertise in some component of the work, and they're world class in it. And that's really what makes things work best, is when we have a very well-oiled machinery and team that knows what they're doing. And a major part of that is the ship and the ship's captain. And so to have someone like Tom, who has the background knowledge in marine biology, who's worked with us before and knows the things that we're doing and sort of what our objectives are, but can integrate that knowledge and maneuver and use the ship really well, it is what allows our science to be successful. If we had to every time turn around and say, boat's got to go here, can we do this? We got to go here, it would make things really difficult. And since we don't get a lot of opportunities to do this work, we kind of put all of our eggs in one basket. And so we need to make sure that we have the best opportunity for success, and that means having the best captain, the best platform, and Tom is that for us. And he may not know why he gets chosen to come on this expedition, but I can guarantee you, when I reach out to Tony and I say we're going to be doing something like this and we need the appropriate platform, it's more we need Tom, because he knows what he's doing and he's part of our team, and the platform is also ideal for what we want to do.
Tom is a very humble man, so Dr. Friedlander, could you maybe talk to us about what his strengths on this expedition were?
Yeah, first off, he's a pretty decent cook. I'm going to tell you that right now. he turns into one of us, kind of one of our family. We are all so close in our group, that, like I said, we all know our roles and what we do well and where we fit into the process. And Tom's ability to be part of that process seamlessly, with a very steep learning curve for understanding what we need to do and how we need the boat to behave. It's really critical for us. And like I said, he's as much a member of the team as anybody else. And what he brings to it in terms of his knowledge of marine biology, of the area, of the animals, of the things that we want to be doing, just allows us to do our science to the fullest sort of capacity possible. And I'm not exaggerating when I say that. We've worked with a lot of different captains and a lot of different platforms, and the success always hinges on the captain. And so we're incredibly grateful.
Yeah, so it's great to have an expert on navigation, on the waters, and also it doesn't hurt that he's an amazing cook. So
yeah, and the other thing is, it takes our mind off of a lot of the other things that we don't need to be thinking about, right? Like, we need to be pretty focused on our science or on the very specific tasks that we have. And Tom takes away all of those other things that we otherwise might have to be concerned with, and those sort of fall on him, and he manages all of those incredibly well. And that's, again, why we're able to be successful.
Tom, can you kind of describe what your daily operations guiding and hosting an expedition, maybe this one in particular, looked like?
The role that I guess that I have to play in all this is primarily, number one, I got to make sure everybody's safe. And I have to make sure that we are where we're supposed to be, we're asked to be at the right time, and when we're following pods of dolphins, we have to be in a certain place, a certain distance and a certain speed, and so there's a lot of moving parts. At night, we have to make sure that all the equipment is back on board and secured. Any of the inflatables the ribs that come out with us, that they're either secured to the side of Valkyrie or they're on a mooring for the night. And it's basically just making sure, like breakfast, if we have breakfast set up in time, that when we go out on our expedition, that we can leave on time for the expedition, not just haphazardly on any schedule. We try to stick to a regular schedule. So communicating with each other, and understanding what the needs of the scientists who are on board, what they need, when they need it, and then just trying to just be there at the right place at the right time. I want to say something about Ari's, Dr. Friedlander's team. I'm incredibly privileged to have been with that group of people. It was fascinating as the team was coming together the first day, talking to them. There are people there from the Netherlands that come over just for this particular project. I mean, they're not here the rest of the year. They're here just for that specific project. People from Washington State, people from, and of course, California. And I started quizzing, say, like the folks from the Netherlands, I said, there are a lot of dolphins between here and the Netherlands. Why here? And their response was, this is the best team in the world, and this is the best project. And as Dr. Friedlander mentioned, this team has been working together for years, this whole group of people. So I was the brand new kid on the block, and that was an extremely, as I said, I was very privileged to be with this group and honored. They've asked if I join them again this coming fall, and I've already said yes, by the way. Anyhow, I just wanted to point that out, that this wasn't just a random team of scientists. This is a very unique group of scientists that do these projects.
It seems like there's a lot of mutual respect and honor between both sides of this, the scientist side and the captaining the vessel side. So that's really great to see. It was a great collaboration.
That's exactly what it is. It's not a transactional relationship in any way. It's very much a partnership and collaboration. Yeah.
I agree.
So Tom, you wore the hat of captain, of chef. Did you get to feel a bit like a marine biologist when you were helping out with this expedition?
Oh, absolutely. The marine biologists, it's a small piece in the whole puzzle, running the boat. As you know, with doing research, it takes a lot of little pieces to put the whole together. So yes, I feel like I was definitely a part. Again, very privileged to be a part of that, a piece of that part in all that.
So, Dr. Friedlander, I'd love to talk a little bit about the science that went on board. So, could you tell us a little bit about how this expedition contributed to our general understanding of the dolphins that you studied?
Yeah, so, first and foremost, for as much as we think we know about these animals, we really don't understand their social lives very well. Either the acoustics, the types of sounds that they produce, the reasons or the context around those sounds, how group structure and cohesiveness naturally occurs. And so as much as we're doing these experiments, we're also learning just about the animals in general. And so we have, just by spending this much time with these different groups of dolphins, and we're talking about common dolphins and bottlenose dolphins mostly for this project, you really do get a sense for what the animals are like and just sort of their demeanor. And like Tom was saying, that first time when you see a response in them, the more you spend time with them, the more you can see these nuanced changes. And so you get used to being with a group of 200 common dolphins and, seeing groups of 15 or 20 that are sort of all together. And then as soon as, a playback occurs, maybe the animals all aggregate together, or maybe they spread out and change their direction. So I think, without going into like very specific minutia about what we're learning, because we're still sort of actively doing this, it's clear that these animals have very tight social bonds, that they're in acoustic communication with each other, and that the sonar impacts how they communicate with each other, the amount of communication that occurs, as well as the types of schooling behavior and movement that we see.
Did you notice differences between common dolphins and bottlenose dolphins?
Absolutely, yeah. Just as a species, I think of common dolphins as maybe a group of deer. They're big, they're somewhat skittish, they're always on the move, they're very athletic. And I think about bottlenose dolphins as they're kind of more thuggish, they're a little bit more kind of brutish, maybe like a pack of dogs, or something. They're oftentimes very social with each other. And, like I said, you get to very quickly, because you're spending so much time with them, you see these sort of differences in their behavior.
Tom, after this expedition, were you kind of able to look at a group of dolphins and say, oh, those are common dolphins, or oh, those are bottlenose dolphins, maybe based off of how they were behaving?
Oh yeah, definitely. It does take a while to identify them from a long way away, and it was always amazing to me in the beginning where they'd look out and from a long way away and call out which species they were. And be right.
Just flipping a coin, Tom. That's all we do.
After a while, you do start seeing the differences in the different behavioral patterns and size, and there's all sorts of identifying ways that you look at them. But yes, you do get to know them a little bit better as time goes on.
That's really neat, and you probably get a deeper appreciation for them as well.
Definitely.
So Dr. Friedlander, can you tell us a little bit about where we could find results from this, or if you're planning on publicizing results, how can we learn more about what you studied on this expedition?
Yeah, it's a great question, and it's something that we have a little bit of capacity to do right now, and there will be more coming. These projects, in order to really get a statistically significant response or knowledge that you can say with some confidence how the response occurred. It takes us years to do this. We have a sort of a week or 10-day period each year when we can go out and do these experiments. And to sort of speak to what we've learned in definitive terms at this point would be, kind of premature. Like I said, we're certainly seeing these different kinds of responses, but we need more data before we can make or draw our real conclusions. Some of the things that we have learned so far, we've published a couple of papers. One was simply on the methodology. No one has ever put together an experiment like this where you're using drones, you're using a field, a station on a cliff, you're using biopsy samples, you're using a big platform. So we've published a paper just on that protocol for how to do this. And then we've actually we've published one other paper on the vocal activity of common dolphins. For as common as they are, we have no idea what the magnitude of the different acoustic calls are that they use and sort of the context around them. So we've published just some baseline, sort of here's what we're doing, here are the species, and here's how they behave. And once we get into the science and can actually publish on the results of the experiments, then we'll have more sort of public opportunity for that. And our goals are to publish in the scientific literature, but then also to present our information as broadly as we can, either through press releases, working with other organizations that do this, or through our nonprofits communication department.
What is your hope for the ultimate impact of this type of study? Would it be noise pollution reduction, more policy? What are you thinking?
There are a few things that I think we are hopeful will come from this outside of just our knowledge of the species. And one is a knowledge of how the things that we are doing to the environment around them are affecting these animals, to the point that we can say, is this just annoying them? Is this something that if they're exposed to over a lifetime will have some chronic impacts on those animals? And if those sort of questions we can answer in a certain way, then absolutely, we want to be able to recommend policy changes and recommend sort of behavioral changes for the groups and organizations that are using this kind of sound. And again, I said it's important that we study the common animals too, because numbers wise, these are the ones that are affected the most. And so we can't not study them just because they're abundant and save that kind of work just for the rare species or the more sensitive ones, but for any animal that is being exposed to this kind of pollution.
Did you have a personal affinity for marine mammals or dolphins in particular before you started this research, or was that something that grew over time?
I've been studying marine mammals professionally since for my entire professional career, and I started studying them academically as an undergrad. So all aspects of them are things that I've become really interested in. And over the course of your sort of career, there's not sort of a straight path, and I started getting in. So I'm not an acoustician, I'm not a physiologist, I'm an ecologist, and I study animal behavior, but I was brought into these projects about 20 years ago because at that time, I was one of the few people that physically was deploying suction cup tags on whales and could do that physical part and go out in the field and be doing that one thing. And that gave me access and opportunity to projects that were going on around the world when this type of behavioral response stuff was starting. And so just by being adjacent to it, I became more interested in it. I learned more about the acoustics and about, what was happening there. And I also sort of bolstered my own capacity to do, analytical things with the tag data. And so it's grown from there. And I've been able to be part of these projects studying sound impacts on animals, like I said, for quite a long time. And it's been really, really exciting and fruitful.
Yeah. That's great. And it seems like this long-term data will be really important to putting these puzzle pieces together to understand these behaviors as we go. And I'm sure as we continue, there will only be more sources of noise pollution. So it's really important to understand those effects.
It is. And sorry, one other thing I'll mention is that A unique part about this study is that the funding agency, the Office of Naval Research, are the ones that fund this work on how Navy sonar impacts animals. And it would be a nice thing if we could somehow work with the other organizations that are creating the pollution, whether it's acoustic or other kinds of pollutions, to help fund the research the way the Navy does to better understand the impacts of that industry, rather than relying on science to go out and raise those funds independently. I do feel like there should be a bit of responsibility from those that are contributing to the problem to help contribute to the solution.
Yeah, I think that's incredible that they're funding this. That's really cool.
Yeah. Katie, could I add something in there too?
Absolutely.
You know, we keep talking about sound equaling sound pollution in a negative sense, but think of another ramification here. If you can identify and control and understand the communication sounds that goes on to marine mammals, think about at some point in time a sound that could be emitted from a ship to a whale that says "stay away." We would eliminate whale strikes if we could harness that understanding and that communications. So understanding sounds and cause and effect isn't always necessarily in the sense of this sound is creating a bad thing. It could ultimately provide a very good thing. Again, it's just more understanding, and so that's the layperson's perspective on some of this as well.
I'm really glad you threw that out there. I think that's an important thing to note as well, especially when we're talking about, vessels being involved in marine research. There's always that kind of, it's a little bit of a paradox of something that might cause noise pollution, but ultimately you're creating knowledge and helping find results that could potentially lead to ameliorating some of those disasters.
Yeah, there's very little that we do that has no impact, but understanding or minimizing that, or doing as much as you can to offset the things that you're doing otherwise, I think is important. And obviously, Tom, folks like Tom, I think probably most of the folks that work with seakeepers that are interested in using their platforms to help support science have that same type of conscience.
Yeah, and I hope there's a lot of resources out there as well for, people to practice safe boating practices. And maybe that's something I can link to later is practicing those safer boating practices around maybe even common areas where marine mammals are present. So those are all really good resources to have available to the public, and I'm sure research like this is only going to create more resources.
Absolutely.
Tom, were there any unexpected or surprising instances that happened on this expedition for you?
Unexpected things. Well, we had a weather issue that prevented us from going out one day, and we had to actually maneuver the boat into a different harbor, different cove, because of how strong the winds came up, and they were very, very nasty. But that's not, in my world, that's not necessarily a truly unexpected thing. I mean, those things happen, so you just deal with them. That's part of being out on the water all the time. I go back to, I think, just the most unique thing from my perspective was just watching the behavioral changes with the dolphins. With the sound emitted underwater, and see how quickly their behaviors changed, and just visually, very, very quick, and that was very unique. So that was unexpected for me.
Dr. Friedlander, I wanted to go back to something you mentioned about having about 7 to 10 days a year to go and do this type of data collection. Now, is that a limitation to your research?
Yes, obviously, we're limited by, the resources that we have available for the projects. Like Tom mentioned, our partners are kind of around the world. And so coordinating all of our schedules, finding a time when we know we have the best chance to succeed based on weather, and when those animals are going to be in the locations where we can access them, and when Tom is available. There's so much that goes into the planning of these things. We try to do 2 7 to 10 day efforts per year to do this kind of work, and all of those things make it You can't just go out, in the morning and decide you want to do this. Like I said, it takes months and months of planning. Even the gear. So the large sound source that we use that is provided to us, there's really only one of those that's in service, and there are other projects and other people that have access to that or want that. So yeah, all of those things make it more challenging for us to get days on the water. But even if all of those stars aligned, we're still limited by the funding from the agencies for that.
Unfortunately, that's such an issue in research in general. So I hope that, Seakeepers can at least help with a little bit in terms of connecting scientists to vessels, and help kind of cutting some of those costs there. Is there a particular reason why you chose California to do this research? Have you ever thought about expanding to other regions, or are you thinking of staying localized for now?
In some ways you pick your battles. We've done this research in the Med. We've done it in the Bahamas. We have an active project on the East Coast of the U.S., off North Carolina. We've been doing this work here off California for the last 14 years at this point. So if this specific work for us really needs to be strategically done in places where Navy activities and operations are. But at the same time, one of the things that we want to do as a next step for this project is do the same kind of work, but do it sort of here in Monterey Bay where I'm located. Because as Tom said, you see the responses by these animals. We measure the acoustic response, we measure the behavioral and the physiological response. But these are animals that we know are regularly exposed to this kind of sound. And so are the responses that we see different than a group that may be naive to these kinds of sounds? And so to be able to compare this population versus a population that is naive will give us a lot of insight as to, are these animals adapting to the sound? Are they just habituated to it or desensitized to it? And that'll tell us a lot more about the likelihood for impacts down the road. So yeah, when the functional work needs to be done sort of around these areas where navies operate, but we really would love to have sort of baseline or naive data from the same kind of animals from slightly different locations.
Yeah, absolutely. So clearly this is ongoing research. I heard you mention that you have plans to go out together this fall. Tom, can you just tell us what you're most excited for going out on another expedition with Dr. Friedlander?
Sure, but before that, Dr. Friedlander, did you say the Mediterranean and the Bahamas? Don't you need a captain for that one too? I'll find the boat.
I'll tell you, man. The Med, fine. The Bahamas, it is hot and sticky, and it's always windy. And we would go down there for a month at a time and end up with 5 good working days. And
rough.
Yeah. I've sworn off on the Bahamas. I'm also a cold weather guy, as you know. So putting me in the tropics is not good for my health. But absolutely, Tom, we can put together a group for that with you. Yeah.
Just let me know. I'm ready. Katie, before I answer that question, can I share with you something else too that I've noticed? As I mentioned earlier, this was our, I think, 3rd time that we've done work together. And what's interesting is the changes in some of the technology that's being used. The very first time that we worked with whales up in Monterey with Dr. Friedlander and his group, the behavioral studies were done by having all these people aboard Valkyrie, and they'd sit up top with binoculars, and we'd find a pod of whales, and you sit there and watch them and record and write down what they're doing. They would plant some tags on the whales by coming in close and using suction cup tags to monitor them, and then that was that. The next year that we did this, all the research switched to behavioral studies being watched with drones, because now you can use that technology to get up in the air, get up high, and monitor a lot more and on a direct basis, and not just from a distance on the boat. And so that was the project last time in Monterey, was taking a number of these people to fly drones on and off Valkyrie. And also, a lot of these scientists were getting ready to then go to the Antarctic to monitor whales in the Antarctic with the drones. So they were also getting a lot of practice in with launching and retrieving drones off of a moving vessel. And of course, I was teasing them about, so in the Antarctic, you're going to be launching from a gyro-stabilized 65-foot yacht, and is that how that works down there? And so, but anyhow, you can see that the changes in using technology and the systems have worked. So then our third project together was the Dolphin project that was over in Catalina Island. So I digress for a minute. I apologize, but I wanted to get that in because I thought that was always very interesting too, to see how over time things have changed to accomplish some of these goals.
That is a really interesting insight. And it makes me wonder, Dr. Friedlander, if advances in technology like this in coming years, do you think that will impact your research significantly and lead you progressing towards more conclusions?
Absolutely. And I couldn't tell you what those are going to be, but I can guarantee you that it's going to happen. Like Tom said, there are new things coming online and new tools that we have at our disposal all the time, and it's really up to us to take advantage of them. So for example, the drones just being a technology to measure animals. That's what we did at first, was measure how big is an animal, how fat is an animal. Well, now we're using them to look at video of how are their groups, kind of changing over time. We actually now are deploying tags using drones. And so, we're sort of figuring out how to use these technologies that we certainly aren't creating, but are taking advantage of to make our science a little bit more efficient and effective. And so there's always going to be something coming up next. And that's part of the fun, is that there's always sort of something, beyond the horizon that's going to help us out.
That's really exciting. It keeps it fresh. It keeps it interesting.
And Tom keeps getting bigger boats too, apparently, so, pretty soon we're just going to be traveling the world with Tom,
Yeah, that's right.
Yeah.
That's right.
Well, I can't wait to see it. I hope you all do travel the world, and I'd love to hear about it when you do. Before we wrap up today, are there any final thoughts or acknowledgments that either of you would like to share?
Yeah, I would like to say, first off, the organization Seakeepers has been so fantastic for us in terms of helping to facilitate our science, to support the science and the things that we think are important. But personally, I've made some great friends. I've gotten to know Tony really well. I've gotten to know Tom extremely well. My only regret is that my work is always on the small boat, and that me and Tom really only get to hang out, either on a crappy weather day or at the beginning of the day or the very end of the day. But I really do think of Tom as critical a part of the team as anybody, but also a really good friend. And I look forward to seeing him as much as I look forward to going down to do the work. And that's just an opportunity that has come up because of Seakeepers, and I'm really grateful for that.
Yeah, I would second that. The friendships have become just enormous, and again, as I said earlier too, is I've been very honored and privileged to work with some incredibly bright and interesting scientists on that professional side, but in the end, we've all become very good friends, and I've enjoyed that, if not more, as well. But that is all a function of Seakeepers putting projects and boats together, and the sky's the limit of what we could do if we do it together.
I think that's a really important aspect of science that people don't often consider, but forming those close relationships that's how we make progress and how we move forwards. So it's really exciting to see you two so close, collaborating so much, and I really look forward to all of the places you'll go together, and hopefully we can speak again sometime in the future and put in a few more of those puzzle pieces.
Definitely.
Absolutely. Yeah.
Great. Well, thank you both so much for joining. This has been incredible. I've learned so much about your work, about these behaviors and the effects of sonar. So this was a really enlightening discussion, and yeah, I look forward to speaking to you both soon.
Good. Thank you.
Thanks for having us.
Thank you to Dr. Ari Friedlander and Captain Tom Peterson for sharing the story of dolphin acoustics and the ways in which noise pollution affects the behaviors of these fascinating marine mammals. Collaborative science was such an important theme in this episode, and we can't wait to see where this research leads. For our final episode this season, we'll be connecting with the Seakeepers Asia team to learn about their conservation efforts on the other side of the world. For more information about our expeditions, including papers published from the data collected, head to the scientist-led expedition page on www.seakeepers.org. Join us next time on Seakeepers Voyages of Discovery, where we'll continue our journey to research, educate, protect, and restore. Until then, fair winds and following seas.